Hey there, welcome to the Punctibyte for both the weeks of November 12th and November 19th. We'll be heading into the Thanksgiving holiday, so next week we will not have any formal lab. As we go ahead and think about that scheduling, I'm going to go ahead and bring up the calendar. Maybe I'm going to bring up the calendar. Seem to have a few spotty issues there. And what we'll see is that this week we'll be doing labs 22 and 23. So we're going to be looking at immunology in lab 22 and water microbiology in lab 23. At the end of the week, Erin and Amanda are going to be manning open lab, but then on the 20th of November, that day we will not have a required lab. And we can talk amongst ourselves about how we want to handle that day, but we have at times done an optional Winogradsky observation during that time. And what I might propose is that rather than all of you coming to lab, I just simply be available in case students want to stop by for roughly an hour's worth of time from each lab section. So for example, I would plan to be there from 9 to 10 and 10 to 11, and then I would be plan to be there again from 2 to 3 and 3 to 4. And then that way, if anyone did want to stop by and just take a look at their Winogradsky column, I would be available, though I would be planning to be working during that time and hopefully working on writing the final exam. So that's the tentative plan. We can talk a little bit more about that in your lab sections, but let's take a moment to look at the TA guidelines for lab 22 and lab 23 and just a few things to think about in both of those labs actually. The immunology lab is a lecture that I would suggest that you only give if you've already taken immunology and or you've studied immunology in some context and you're really comfortable with this. It can be a little bit of a difficult lecture because we're trying to pack in the entire introduction to immunology in just one lab. Towards those ends, I have a couple of demos that I usually show. If you do decide that you want to do this lecture, let me know and I'll get you geared up with all of those demos as well so that you can just do it up. And in terms of the lab portion of this, there's actually 3 segments of the lab, and I usually split the class so that not everyone starts with the same thing. So we can have one bench begin with the right stain blood smears, one with Octoloni, and finally one with the blood typing. One note on the blood typing is that the blood we will be using is not real blood. It's called neoblood, and it's actually a chemical precipitation reaction. So there is no danger of bloodborne pathogens to the students when working with this. However, I think it's not a bad idea to try to start to teach them about the techniques that they would use if they were using real blood. So to have the gloves available and to talk to them about how that would be an important part of personal protective equipment for working with anything that could contain bloodborne pathogens. I think that wraps up lab 22 pretty well, and lab 23 is water microbiology, fairly in depth, and I know for some of you this is a very favorite subject, whereas for others of you this may not be something that you find particularly interesting. Although I suppose there's interest in it for everyone, even if you're more interested in medical, because certainly waterborne pathogens are of great concern. And in fact, I thought that might be our note of current events right now. It's been on my mind. What about with this Hurricane Sandy in the east, in the northeast? What are we thinking about as far as possible infectious disease ramifications of that? And I found a couple of little articles on it. I imagine some of you maybe have seen some others. This one that I was just looking at is one about how there was a school closure because the school that they were using as a shelter for the storm, actually there were 13 young people who got infected with a very infectious virus, and it spread throughout the shelter, causing them to have to close the shelter. So this sort of adds insult to injury in times of disaster, and maybe something that has been on your mind as well. And I thought it's possible that that may be something current event wise to interlace into your coverage of water microbiology if you've found any good articles, and certainly feel free to share those with us if you do find some articles about waterborne pathogens in the wake of the storm in the Northeast. There's a lot of notes on this because one of my TAs did an excellent job of rewriting the TA guidelines at one point. So she has put in quite a bit of additional detail into these TA guidelines. So there's a lot there for you to use if you need. And also during this lab, maybe it's helpful to surmise sort of the big picture view for the methods that we use to detect coliforms in water. And remember, of course, coliforms being the indicator organisms of contamination of water, fecal contamination of water. So I'm just going to jot a quick note of sort of the overarching methods that we use to detect coliforms, because I think this big picture sometimes ends up escaping students. And it's an important thing to remember that this is the sort of big picture view. Here are the 3 methods that we're using to detect coliforms that are commonly used in water treatment and wastewater treatment plants. The PA test, now this is a presence-absence broth. It's a qualitative assay. It allows us to know whether or not there are coliforms in the water, but it doesn't tell us how many in any way. It also doesn't necessarily differentiate fecal from non-fecal coliforms. However, we are adding MUG to our test, and MUG will be modified in the presence of beta-glucuronidase enzymes from E. coli, and it will become fluorescent. And so this does a better job of allowing us to know that these would likely be fecal if we see the fluorescence from the MUG. Now, the next method is actually the most confusing for everyone. It's a multiple tube fermentation method, and the first step in it is where you use the multiple tubes. The first step is called the presumptive test, and that's where you actually do have 9 different tubes of different volumes of water, and you're looking for that statistical profile that allows you to estimate the number of coliforms per 100 mils. The second method then, or the second test, is the confirmed test, where you do either an EMB or like a McConkey MUG. We're going to do a McConkey MUG. And then finally is the completed test. And in the completed test, you'll be looking to try to, sorry, my pen is misbehaving on me, but the completed test is where you will be looking to just further confirm lactose fermentation. So by now this looks pretty ugly, but completed is what we're looking for there. And then let's end things up with the MF test, membrane filtration test. This is the only direct count of coliforms that we do. And this is the test that I'd like you to be ready to possibly demo, but if you aren't comfortable demoing it, just make sure that I know that, and during your lecture, for example, I can demo the MF test. So it's just kind of tricky. We've had a lot of sewage backlogs because of the improper placement of filters in the membrane filtration apparatus. So let's make sure that we get that right, so that we don't have any of those wastewater backlogs or oh man, disasters we've had in the past, flaming ethanol bottles, bombs, it's ugly. So let's try to keep that to a minimum. Hopefully that helps with sort of the overarching view of what's going to be going on in Lab 23, and I think that covers just about everything. I guess just one more brief reminder that we will be heading into Thanksgiving and students will be turning in their unknown reports. Remember that they are due on Thursday for those not submitting it with a late coupon, and then on the 20th for those that are submitting it with that late coupon. Do bear in mind that in addition to the grading key that's their submission edition, right? You're going to have them tear that out of the lab manual and turn that in. In addition to that, if you're looking for a more blow-by-blow rubric, that is actually provided on your TA jump drive. So that folder does have in it an additional, like, more extreme rubric that'll help you with each tiny little point. I should also mention that, remember, we're having them also fill out their lab manuals. So we need to all have a way that we decide we want to check that those lab manuals are filled out, and that the point of that, right, it's not so much to make extra work for them. The point of that is to make sure that they're synthesizing their table entries on their own, that they're making those entries on their own in their lab manual and then retyping their own entries as opposed to copying and pasting things from the summary of biochemical tests. So that full synthesis is really what we're looking for there. I hope you all had a wonderful weekend, and I can't wait to see you on Tuesday.